So to divide by a fraction, remember, you just multiply by the reciprocal. We'll do the same exact thing when you divide by rational expressions. So if you had 1/4 divided by 3/7, let me make that 2/7 actually, okay? You would simply do 1/4 times 7/2, multiply by the reciprocal, and then multiply straight across 7/8. Or if you had, say, 3/4 divided by 9/16, you would do 3/4 times 16/9. Then you could cross reduce, and you would get 4/3. Okay? So, when you divide by a rational expression, you just multiply by the reciprocal. So if you have a rational expression here and a rational expression here, you just flip the second one and change it to multiplication. If you have a rational expression over top of another rational expression, you take the one in the denominator, flip it over, and multiply. So we'll go through several examples so you can see. So you have 4/15n cubed divided by 12/25n. Well, you just flip the second fraction and multiply. Okay, it's called multiply by the reciprocal. And then from there, it's just what we learned in the previous video. You cross out common factors and then multiply straight across numerator and denominator. So you could cross reduce the 4 and the 12 to a 1 and a 3, the 25 and the 15 to a 5 and a 3, and the n cubed and the n. This n cancels, so the n cubed will become n squared, and multiply straight across the numerator and denominator, you get 5/n squared. Okay, here's 2 for you to try. Go ahead and pause the video and hit play when you're ready. All right, so the first one, 15y squared over 4x, will be multiplied by 8x cubed over 5y. The y squared, the 15 and the 5 cancel. The y squared and the y cancel to just a y. The 8 and the 4 cancel to a 2 and a 1. And the x cubed and the x cancel to an x squared and a 1. So if I multiply straight across the top, I would get 6x squared y over 1, which you could really just write as 6x squared y. Okay, now here's the thing. If the denominator reduces to just a 1, that's like you're dividing by 1, so you just write 6x squared y. But if the numerator reduces to 1, you can't just like get rid of the 1, because you need that placeholder to show that the rest of the problem is in the denominator. All right, the second one, you have 12a squared over 5b times 6b squared, multiplied by the reciprocal, over 25a. Okay, so your a squared and your a cancel to a 1 and an a. Your b squared and your b cancel to a b and a 1. And then your 12 has no common factors with the 5 and the 25, and neither does the 6. The factors of 6 are 2 and 3. There's none in the 5 and 25. And the 12 has factors of 2 and 3 also. So you just multiply straight across the top, you get 72ab over 125, and that's your answer. Pretty cool, huh? All right, let's talk about dividing a rational expression with polynomials. So if I have 2x plus 6 over x squared divided by x plus 3, that's similar to when you had like 3/4 divided by 9. Remember what you did to divide that by 9? Remember you made it a fraction over 1, and then you multiplied by the reciprocal. And then you went from there. I'm not going to finish that. Well, same thing here. Think of the x plus 3 as being a fraction over 1, and then multiply by the reciprocal of it. Now notice, it doesn't look like there's any common factors, but the numerator of the first fraction has a GCF that you could factor out of 2, and then lo and behold, you have a common factor of x plus 3 that can cross reduce. And then if you multiply straight across, you get 2 over x squared. How about this one? Again, doesn't look like you have any common factors to start off with, But when you're dealing with rational expressions, one of the first things you always want to do is factor things if possible. So I'm going to multiply first by the reciprocal and then factor the 4 out of the denominator here to give me 4 times a plus 1. And then you can see there's a common factor of a plus 1. So then you just have a minus 2 over 4 times a plus 5. Oops. Or you could write that as a minus 2 over 4a plus 20. Okay? Cool. All right, so here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So here you have 4d minus 8 over 2d minus 6 times d minus 4 over 2d minus 4. Now be careful, this d minus 4 and this 2d minus 4, you can't like cancel that. And this 8 and 6 and these 4 d's and those things, you can't cross-reduce those because they're part of a subtraction problem. You have to have it multiplied as factors. Okay, but the numerator here, you can factor out a 4 and you get d minus 2. In the denominator, you can factor out a 2 and get d minus 3. Here you have d minus 4. Here you can factor out a 2 and get d minus 2. Now you can cross out common factors. This 2 and this 2 cross-reduce with the 4 to make those all 1s. The d minus 2 and the d minus 2 cancel here to make 1s. And then when you multiply straight across, you would just have d minus 4 times 1 times 1, which is d minus 4, over d minus 3. And then that's pretty much it for that one. Pretty cool, huh? All right, the next one, you have b plus 4 over 3b plus 2. And you can't factor anything out of that one. So multiply by b plus 1. And then the 3b plus 12, I'm going to flip it to the denominator and factor out the 3 at the same time. Okay? So you could see that you have a common factor of b plus 4 here. So the numerator would just be b plus 1 over 3 times 3b plus 2. And you could leave it like that, or if you want to distribute the 3, oops, you could write it as 9b plus 6. Either way is good. Alrighty? Okay, sometimes you must factor a quadratic expression before you can simplify the quotient. So for example, here, it doesn't look like there's any common factors to start off with, plus it's also division, so you have to flip it and multiply. But let's take the original expression, and then you multiply by the reciprocal of the second fraction. Then we can factor some things. Notice that this is a trinomial here, so you can find factors of 16 that add to negative 10, which are negative 2 and negative 8. And then y squared minus 9 is difference of squares, so it factors into y minus 3, y plus 3. Now you can see you have a couple common factors. You have a factor of y minus 3 and a factor of y minus 8. So those cancel, and you're left with 1 over y minus 2 times y minus 3. Again, if everything in the numerator cancels, you have to have a 1 there as a placeholder to show that the numerator is still there. If you just wrote y minus 2 times y plus 3, that would be wrong, because that would imply that it's not in the denominator. Okay? Now, if you want to FOIL that out and write it as y squared plus y minus 6 underneath the 1 like that, that would be fine. But you can leave it in its factored form like this. Okay, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So the first one is difference of squares. So p minus 2 times p plus 2 all over p, or 5p, times p plus q over p minus 2. So the p minus 2's would cancel. There's no other common factors, so you have p plus 2 times p plus q all over 5p. And that's it. The second one, you would factor the numerator as q plus 1 times q plus 2 over 12 times q squared plus 4. Now that's sum of squares. It's not going to cancel or factor rather, over q plus 1. The q plus 1 cancels, and that's about it. So you would have q plus 2 times q squared plus 4 all over 12. All right. Pretty cool. All right, guys, that's it for this section. Please continue on to your assignment. And as always, if you have any questions, don't hesitate to reach out. Take care.